Hi everyone, welcome to section 4 of Big Data Analytics using Apache Spark. At the end of this section, you'll be able to work with Spark Structured Streaming. This section is about Spark Structured Streaming applications. You will learn about an overview of structured streaming such as what it is, use case, introduction, how structured streaming queries are processed, the processing model, as well as a demo on transforming a streaming data frame to calculate word counts. First of all, what is structured streaming? Structured streaming provides fast, scalable, fault-tolerant, end-to-end exactly once stream processing without the user having to reason about streaming. Here is a use case about how Apache Spark structured streaming helps smart manufacturing. In this use case, they have tested for Spark-centric Internet of Things IoT data platform for printed circuit board manufacturing. Also, this is an end-to-end data platform which involves data acquisition, transmission, analysis, as well as storage. Actually, they want to enhance the production process of predictive fault repair and production line material tracking efficiency. In fact, with the help of leveraging Spark structured streaming, they were able to reduce about half of the labor force for the production lines. As a scalable and fault-tolerant stream processing engine, structured streaming is built on top of the Spark SQL engine. In case of static data, you can write your streaming computation code in a similar fashion as you would write for batch computation. You can use the dataset data frame API in Scala, Java, Python, or R to code streaming aggregations, event time windows, stream to batch joins, etc. In fact, structured streaming ensures end-to-end exactly once fault-tolerant guarantee by means of checkpointing as well as write ahead logs. When you think of the processing model of structured streaming queries, or in fact the types of processing engine, you have two options, namely the micro-batch processing engine and then continuous processing engine. With micro-batch processing engine, data are processed as a series of small batch jobs. Also, it has end-to-end latencies as low as 100 milliseconds. It also supports exactly once fault-tolerant guarantees. On the other hand, using continuous processing engine, you can achieve end-to-end latencies as well as low as 1 millisecond. On the other hand, this is an experimental low latency processing mode which was introduced in Spark 2.3, and it has at least once guarantees. When we think of the processing model, structured streaming express your streaming computation has standard batch-like query as on a static table. Also, it continuously processes live data streams as a table. It is similar to a batch processing model. In fact, Spark runs it as an incremental query on the unbounded input table. In this case, new data item from the unbounded data stream will be new data being appended to this unbounded table. Let us see a demo. In this demo, we are going to showcase how to transform a streaming data frame to calculate word counts. So here we have two terminals. So we are going to create a streaming data frame that represents text data received from a server listening on local host and transform it as a data frame to calculate the word counts. So on terminal 1, let's create a data server by running netcat. Netcat is a simple Unix utility that reads and writes data across network connections. In case if you are using Mac or Linux operating system, you can use nc. Here nc is the Linux command for running netcat, followed by the option L, which represents listen for an incoming connection, and then K, which says stay listening for another connection after its current connection is completed, and followed by the port number. In this example, we are using 7777 as our port number. In short, any lines typed in this terminal 1, which runs the netcat server, will be counted as well as printed every second on this terminal 2. On this terminal 2, let's run our Spark shell. As said earlier, here we are going to create a streaming data frame which represents the stream of input lines from a connection to localhost 7777. Here, text is the streaming data frame which contains the streaming text data. Also, it represents an unbounded table. Next, we are going to transform this streaming data frame named text by splitting the lines into words. And then we are going to calculate the running word counts with the help of group by transformation. Also, we want to query. I see an error. Let me find out what is the error here. Let's execute this. And then again we will type it again. Also finally we type query.await termination. So whatever you type here, for example, if I can type Happy Christmas. As you can see, the word Christmas appears once and the word happy appears once. Similarly, I can keep on typing. This time I type Happy New Year. So this table gets appended, and now the word happy has the value as 2 and so on. You can also type a different, for example, happy day. Again, the value is appended.